MCV4U1 Chapter 4 Curve Sketching Session 4. This session we work on questions assigned on page 169, 170 and 171 from the last session. Question 1. Determine the point at which f prime of x equals 0 for each function. Part A, f prime of x is 3x2 plus 12x. If we set it to 0, 3x2 plus 12x equals 0, we have 3x times x plus 4 equals 0. That means x is 0 or negative 4. F of 0 is 1 and f of negative 4 is 33. Therefore, at 0 and 1, negative 4 and 33, f prime of x equals 0 when f of x is x3 plus 6x2 plus 1. Question number 3. For each of the following graphs, state the interval where the function is increasing, decreasing at the point the tangent line is horizontal or derivative is 0. Part B. B for negative 1, the function is increasing. So for x is less than negative 1, it is decreasing. For x is between negative 1 and 1, it is increasing. And if x is more than 1, function is decreasing. At negative 1 and 1, the tangent line is horizontal. Question 6. Sketch the graph of a function that is differentiable on interval negative 2 and 5, close interval negative 2 and 5, and satisfies the following conditions. The graph of f passes through the point negative 1 and 0, 2 and 5. The function f is decreasing when x is between negative 2 and negative 1, increasing between negative 1 and 2, and decreasing between 2 and 5. The function is passing through negative 1 and 0, 2 and 5. Between negative 2 and negative 1, it is decreasing. Between negative 1 and 2, it is increasing. And then it is decreasing again between 2 and 5. The graph is something similar to this. Obviously, the graph is not unique. Another option could be joining these points by a straight line. The value of the function at negative 2 and 5 are unknown. Any y value can be chosen. Question number 7. Find constants a and b such that the graph of f of x equals x3 plus ax2 plus bx plus c will increase to the point negative 3 and 18, decrease to the point 1 and negative 4, and then continue increasing. Since the function is passing through these 2 points, f of negative 3 is 18, and f of 1 is negative 14. Since f of x increases to negative 3 and 18 and then decreases, f prime of 3 is 0. Similarly, f prime of 1 is also 0. We set a system of equation corresponds to each of these conditions and solve the system of equation. Since f prime of 3 is 0 and f prime of x is 3x2 plus 2ax plus b, 27 minus 6a plus b is 0. 3 plus 2a plus b is also 0. F prime of 1 is 0. And using these two equations by elimination or substitution method, we can conclude a is 3, b is negative 9. F of 1 is negative 14. That means 1 plus a plus b plus c is 14. We know the values of a and b, 3 and negative 9. Then we can find the value of c, which is negative 9. Question number 8. Sketch the graph of a function f that is differentiable and satisfies the following conditions. F prime of x positive when x is less than negative 5. That means for x less than negative 5, function is increasing. Between negative 5 and 1, and when x is more than 1, derivative is negative, function is decreasing. F prime of negative 5 is 0, f prime of 1 is 0, f of negative 5 is 6, and f of 1 is 2. X-axis, y-axis, f of negative 5 is 6, f of negative 5 is 6, f of 1 is 2, f of 1 is 2, f prime of negative 5 is 0, tangent line is horizontal. F prime of 1 is also 0, tangent line is horizontal. When x is less than negative 5, function is increasing, or less than negative 5, it is increasing. Between negative 5 and 1, it is decreasing, and it's going to be decreasing after x equals 1. The graph is something similar to what we drew here. This is important to know at 1 and 2. The tangent line is horizontal. Basically, the tangent line is passing through the graph of the function. Question number 11. For f of x equals x4 minus 32x plus 4, find where f prime of x is 0. F prime of x is 4x3 minus 32. If we set it to 0, we get for x3 equals 32. That means x3 equals 8, or x is 2. The interval on which the function increases and decreases, and all local extrema. We draw the sign chart for the derivative of the function. Derivative is 0 at x equals 2. For x is less than 2, derivative is negative, and for x is more than 2, it is positive. Therefore, the function decreases for x less than 2, and it is increasing for x more than 2. Point 2 and f of 2 is the local minimum on the graph of the function. Thanks for watching.